All right, so today we're going to wrap up factoring trinomials, okay? And so right before this, we did special products, right? And before that, we looked at trinomials like this, quadratic trinomials. But we looked at examples where this a value was equal to 1, right? Where we didn't have a coefficient in front of x squared. But today we're going to look at examples where we have a number. What do we do when we have a number here, when a is not equal to 1? Okay, and so if we look at this example, 2x squared plus 7x plus 5, we can definitely use trial and error, right? And what I mean by trial and error is that we know that we're going to have two binomials for our factors, right? And we're going to have x's here. And we know that when we multiply this term by that term, it has to equal 2x squared, right? And so for 2, we only have two options here, right? Our options are one of these has to be 2x, and one of them has to be an x, right? Because the only factors of 2 are 2 and 1. And we know that the last thing we're going to do when we distribute here, when we multiply, is that these two integers have to multiply to give us a product of 5. Okay, and so the good thing about this is that 5 also only has two factors, right? And so we can, let's say we put a 1 here, right? We put a 5 here. Let's see what happens, right? We get 2x squared. And then we do 2 times 5, right? 2x times 5. We get plus 10x. Then we get plus an x and plus a 5. And so although this setup here, these two factors give us a 2x squared and the 5, our middle term doesn't match, right? We have 7x. This is going to give us 11x, which means we have to switch the positions of these two. Now, if I take that 5 and bring it here and put the 1 there, let's see how that changes things up. We got 2x squared plus 2x plus 5x, and there we go. We get that 7x, right? And so that's how we do the trial and error, right? But you can probably imagine that this can get pretty complicated, right? If, let's say in this case, we really only had two options because 2 and 5 are prime. But what happens if we get numbers like 12 or 24, right, that have a bunch of factors? Then the trial and error can get a little bit overwhelming. Okay, so let's talk about how we can guarantee that we can get the right setup, okay? So let's re-look at this example. I'm gonna rewrite it right here. We get 2x squared plus 7x plus 5, okay? And so before, when we had a polynomial maybe like this, we would do the product and sum game, right? We're going to do something similar, but instead of solely looking at this 5 for the product, we actually have to take the product of a times c, okay? And so let me pick a color here. Say a is 2 and c is 5, right? So we want a product of a times c, which in this case is 10, and we want a sum of our middle term, 7, okay? And so here's what happens here. Once we figure that out, we need two numbers that multiply to 10 and add up to 7, right? And so those numbers are going to be 5 times 2, and this is 5 plus 2, right? And so what we can do is we can take this middle term, the 7x, and we can write it as a sum of these two numbers, okay? So I'm going to take this trinomial, and I'm going to turn it into a 4-term polynomial. So I'm going to write this as 2x squared plus 5x plus 2x plus 5. So all I've done is I've taken that 7x and chosen to split it up this way because I know that 5 times 2, right, we figured that out using the product and sum tool. And here's what happens. Now we have 4 terms. And we did this when we factored GCFs, right? When we didn't have a common factor between all 4 terms, we can then look for common factors between pairs of terms, right? So let's look at these first two. 2x squared and 5x have a GCF of x, right? So if I factor out that x, I'm going to be left with a 2x plus 5. And now the 2x and the 5 don't share a common factor, but look what we have. We have another 2x plus 5 here, right? So I'm going to write this as plus parentheses 2x plus 5 to kind of show a new GCF, a new binomial GCF of 2x plus 5, right? So we're going to factor out that GCF one more time. If I factor out the 2x plus 5, I'm left with an x plus a 1, right? And why is it x plus 1? Because if I take 2x plus 5 and divide it by itself, I'm going to leave that 1. It's important for that 1 to be there, because without it, then, that 1 is there to hold the place of that 2x plus 5. Okay, so quick recap. Yes, we can guess and check, trial and error, but we can also use grouping, right? And the way we do that is we start with a product of a times c, a being our first term, our coefficient of x squared, and c being our constant. So in this case, 2 times 5e is a product of 10. So we want the two numbers that give us a product of 10 and a sum of our middle term 7. So those numbers are 5 and 2. And now you might be asking, does it matter which way we put, like what would happen if I put the 5x over here and move that 2x over here? You actually still end up with the same thing. It's going to look a little different, but you're going to end up with the same GCF, okay? And if you try that over here on your own, I think you'll figure that out, okay? So let's just try a couple examples. So let's look at 7x squared plus 22x plus 3. So like I said, all of these are in this form, ax squared plus bx plus c. So we want a product of a times c, which in this case is 7 times 3 or 21. And we want a sum of 22. So like I said, sum of 22. And we want a product of 7 times 3, okay? And so let's play around with those factors of 21. 3 plus 7 is going to give us 10. 21 times 1, 21 plus 1 is 22. And so the numbers we want are 21 plus 1, okay? So we're going to take this and use that to rewrite this 22. So let's rewrite our polynomial here. We get 7x squared plus 21x plus x plus 3, okay? And so if I combine these like terms, it's going to give us my 22x, but we want to split it up into 4 terms, okay? That's what we're doing here. So then we're going to split it up and take the GCF of each of these. Actually, for this example, so just it turns out a little different than the last one, I'm going to switch these two. Whoop. There we go. So GCF of 7x squared and x is going to give us x times 7x plus 1. Now the GCF of 20x and 3 is 3. If I factor out that 3 for these last two, I also get a 7x plus 1. So we now have a binomial GCF of 7x plus 1. So then we're going to factor out that 7x plus 1, and we're left with the x plus 3. Okay, so hopefully you're seeing that this method is taking away the guessing, right? Once we figure out kind of the numbers that make this work, we can very systematically break it up and factor using GCFs to end up with our our fully factored form, okay? All right, 4x squared plus 7x minus 15. So in this case, we have an a value of 4, right? And our c value is actually negative 15. So when I look for a product of a times c, that's going to give me a product of negative 60. And I want a sum of 7, okay? So this might be a little less clear, right? But let's just play around with some numbers. So I want factors that have a difference of 7, right? Because one of them has to be negative because this is a negative number. So 6 and 10, right? 6 and 10, like those combinations wouldn't work because negative 6 and negative 10, that's going to give us a difference of 4, of negative 4. So let's play around with some other factors of 60. 3 and 20, that gap is too big, right? And our numbers we want are 5 and 12, right? Now if we want a sum of positive 7, I need a negative 5. So 7 is negative 5 plus 12, okay? So let's rewrite that 7x using these two numbers. So we get 4x squared minus 5x plus 12x minus 15. Okay? And so if I break it up into pairs, my first GCF is going to be x. I'm left with 4x minus 5 plus, we have a GCF here of 3. I'm left with another 4x minus 5, right? So the goal here is to get these two to match up, right? So if you factor out a GCF here and it didn't give you a 4x minus 5, that means we either A, we did something wrong here, or it isn't factorable. Well, actually, I think it is factorable. If this works, then it's definitely factorable. So it's a good way to check your work. Okay, GCF is 4x minus 5. So when we factor out the 4x minus 5, we are going to be left with x plus 3. Cool beans? Beans. Okie dokie. I wonder why I wrote be careful. Okay. A times C is 36. We want a sum of negative 13. So let's think. 6 times 6? No. So here's the thing. We want a negative sum and we have a positive product. That means both of those factors have to be negative, right? So negative 6 plus negative 6 is negative 12. Maybe 4 and 9. Yeah, that's it, right? This is negative 4 times negative 9. And negative 4 plus negative 9 is going to give us that negative 13. Okay, that's the magic combination. Combo. Wombo combo. All right. 6x squared minus 4x minus 9x plus 6. Like I said, the order in which we place these two middle terms doesn't matter. Now let's take the GCF of these two. We get a GCF of 2x. We're left with a 3x minus 2. Okay, so if I look at these two right now, the GCF I could say is 3, but if I factor out a positive 3, it's going to leave me with a negative 3x plus 2, which doesn't exactly match, right? We have opposite signs here, which means instead of factoring out a positive 3, I'm going to want to factor out a negative 3, right? Because that negative 9x divided by the negative 3 is going to make this a positive 3x, and it's going to make that 6 divided by negative 3, which is negative 2. And that's what's going to get us to match up here. Okay, so that's one thing you might run into that you have to be careful for, but it's an easy fix. You just make the GCF negative, you can flip, change the signs of each of what's left. So we get 3x minus 2 times 2x minus 3. Okay, so like I said, we're getting rid of the guessing. Okay, now let's look at this one. Okay, we might be tempted here to just say, hey, A times C is 6 times negative 21, which is negative 126. And we want a sum of negative 15. So negative 126 is not an impossible number to break down, okay? But if we were to go along with this and not take care of our first step, we would actually be wrong because it's not technically factored completely. So let's pause here. And I've said before that the first thing we're always going to check for is a GCF. So if we look, 6x squared minus 15x minus 21, yes, we have a GCF. The GCF is 3. So not only is this going to make our life easier, but it's also the correct way to do this. So if you can take out a GCF, always do. It will always make your life easier than having to try and pull one out at the very end. Possible, but, you know, let's do it first. So we take out the 3, we get 2x squared minus 5x minus 7. So one thing is we can't forget about this 3, okay? He's right here. So 2x squared minus 5x minus 7. Now when we do the product of A times C, we get negative 14, and we want a sum of negative 5. So much better than dealing with negative 126 and negative 15, right? Here we want negative 7 times 2, because negative 7 plus 2 is going to give us that negative 5. Okay? It all works. It all works out. Woo! Okay. 2x squared minus 7x plus 2x minus 7. Okay, I'm not going to forget the 3. I know you thought I forgot, but I didn't. So here we get a GCF of x. We're left with the 2x minus 7. And we already have a 2x minus 7. Yay, which means that when we factor out the 2x minus 7, we're left with an x plus 1. And we're donezo. Psych! Don't forget the 3. Don't forget the 3. 3. Okay? This is our completely factored answer. So from now on, you're going to see the directions that, hey, completely factor this polynomial. That includes GCFs. Okay? And so the only tricky thing is there's so many methods, right, and ways to go about factoring things. The good thing is, like, this last method is always going to work. But we have kind of our special products and those things that can help make it easier. So we don't always have to go through this process. Hopefully that made some sense. Feel free to go back and look through some of these examples. I'll be available during office hours if you need me. And yeah, we're just going to practice factoring a bunch. Okay. All right. Bye-bye.